So now we're to the back side of the review. And one of the big concepts we deal with, first of all, notice now that partner B is on the left and partner A is on the right, because that's the way it copies. Anyways, one of the big ideas of a binomial distribution, so let me go ahead and I'll do partner B right now, 500 and 0.03. Let me plot the distribution. So one of the big ideas of binomial distribution is that if your sample size gets really large, then it actually starts to look like a normal distribution. It's actually very hard to see. I hit it and I turn it on, and it's pretty much right there on that. And actually, a cool thing to know here is if you're using the Staplet, sadly, I don't think the NumWorks does this, neither does the TI. It will actually calculate your mean and your standard deviation for you there. Let me go ahead and do, always round to 5 decimal places. Let me just do that. There we go. All right, and if I hit go, plot distribution, now we have more. Admittedly, it's throwing extra decimals there. That's fine. So anyways, I know my mean is 15 and my standard deviation is 3.8145. So you can't, if you're going to do the Staplet, that's fine, but I need to see the formulas. So here you see there's the mean. I took n times p, and this is on your math chart. Let me go ahead and make a copy here, because I know some of you only, here, I think I'm not seeing what I need to see. There we go, copy, and then I'll just paste it again. This is on the formula chart that I share with you, okay? So for this one, n is 200 and p is 0.06. So I'm going to go, let me go fix that number. 200 times 0.06 is 12, right? And then here I have 200, I'm calculating the standard deviation, times 0.06 times 0.94. Take the square root of that is 3.359. So first of all, we got 3.814 for the binomial. Yep, pretty much 3.814. And then when we have 200 and 0.06, so I'm doing both partners right now. You can see the mean is 12 and the standard deviation is about 3.359, okay, which is what I have there, okay? So the work you would show me is actually drawing a square root of this function of 200 times 0.06 times 0.94. Some of you asked me, what's with the stars? Well, I could put x's in here, but the problem is if I put an x, you might actually think it's an x. And I need to show multiplication in some way. And actually, maybe I can put a nice dot. We'll see. You're probably going, Mrs. Overman, just catch up already. There might be a nice dot in here. I don't think so. Is there? I don't see a nice dot. Sorry to say. Ooh, but that looks like a times. Yeah, that doesn't look like an x. That looks better. So maybe I'll go ahead and fix my equation so they look prettier. Okay, so anyways, there's your mean and your standard deviation. So one of the big ideas is we can use a normal distribution because we're actually much better. In the old days, the calculators couldn't handle large sample sizes, so they'd have to change to a normal distribution. And there are lots of statistical tests we do, and we're very good with the normal distribution. So in this case, it's good for you to understand that you can take a binomial distribution and actually use a normal distribution instead, especially since some of the calculators act a little wonky on these questions. So here we go. If I have using the mean, standard deviation, and a normal approximation. So I have, there's my mean, 15. There's my standard deviation, 3.814. Let's show you how to do that. So we'll go back to the original Staplet, go to a normal distribution. I think we said 15 and 3.814, right? And let me make sure, pretty sure those numbers are correct. There we go. Give me 1 sec. There we go. Yeah, 15 and 3.814. And I want to know the probability, how many goggles should I have if I want to cover 75% of the time? So that means I'm going to be starting from the left. So I actually want to calculate a value, not an area. And my area I want to be 0.75. So I'll go 0.75. And it says left tail. Calculate. Go ahead and click the dots. And boom, there you go. I'm getting 17.57. So for partner B, I got 17.57 some. And I would need 18, not 17, because it's actually a little higher than 17, right? It's a little higher than 17. So we want to make sure that we have enough. So we would need 18, all right? On the right side, I can do the same thing. My mean is 12. My standard deviation is 3.359. So let me go ahead and change it. 12, 3.359. Plot the distribution. And then this time I want to be 65% sure of having enough. So I only need the left 65% of the graph shaded in. Calculate the values, and I get 13.29. Interesting thing is, we're still going to round up that 13.29 to 14, because 13 is actually not quite enough to hit 65%. I would need 14. And then just a quick talking about what does work look like on these equations. So first of all, you can always do an equation filled out for geometric or binomial, and you don't even have to label. The equation itself is a reference. So it kind of tells us that you know what you're doing, because guess what goes in the equation? Well, first of all, the actual equation tells us which one it is, geometric or binomial. For geometric, we would have P in there, and then we would have your X, right? For binomial, we would have N and P and X. And then for normal, that's a different beast. We would have mean and standard deviation. I should know what your boundary values are. Okay, so if I need to know where you're starting and where you're stopping, is it to the left? Is it to the right? So if you look up here, like on the normal, I can tell here what you're doing. Up here, if I had on these earlier problems, you can see that I really should write. See, I wrote there binomial distribution, n equals 200, p equals 0.06, x is less than 20, and then I have 0.921. So that's what work looks like. I really only want pictures on normal distributions if you're not using calculator notation. And personally, I prefer the pictures and all these values. Even if you are using a calculator, this is actually, in my opinion, a better format. So, and then finally, make sure your probability statement, that is probability of x is something, all right? So equals some number. So that's what I'm looking for work. Good luck on your quiz.